So let's talk about practically working with Kd. We've got the theory now, and the theory says that Kd is really the equilibrium constant between the aqueous and the organic phase of a solid or an organic compound being dissolved into two phases. And when we rearrange it, we get this relationship that Kd is the grams in the organic phase times the volume of the aqueous phase divided by the grams of the aqueous phase times the volume of the organic phase, with the total grams of whatever is being dissolved equal to the grams of the two phases, grams in the organic phase and grams in the aqueous phase. And that last part is just a mass balance. If we know how much should be in their total, then the sum of the mass in each phase should be equal to the total. So let's talk about two aspects of this. One is finding Kd, the other is calculating the mass of one compound in one phase versus the other. So let's start with a simple example. We have 100 mLs of the organic phase, 150 mLs of the aqueous phase, and we've got 1 gram in there. How do we figure out how many grams are in each phase? Well, to do this, plug in the numbers we know. Kd equals grams in the organic phase times 100 divided by the grams in the aqueous phase times 150. And also 100 equals grams in the equals grams in the organic phase plus the grams in the aqueous phase. We have two equations and two unknowns, because in this example we know what Kd is. So we're going to have to solve for one variable. It's arbitrary which one you pick, but let's go for grams of the aqueous phase. So to do this, we're going to make the substitution that the grams of the organic phase is just 1 minus the grams of the aqueous phase, and that comes from that relationship there. Now if we plug it in, the grams of the organic phase is 1 minus grams of the aqueous times 100 divided by the grams of the aqueous times 150. And I'm going to simplify this on top to give us times 1.5. And this is just simplifying the algebra here. All right with y'all, I'm going to erase this. So now I need to solve for grams of aqueous. So I get grams of the aqueous phase times Ka times 1.5 equals 1 minus grams of the aqueous phase. Bring everything over. Grams of the aqueous phase, Ka times 1.5 plus 1 equals 1. So grams in the aqueous phase is just 1 divided by Ka times 1.5 plus 1. So all I've done is just algebra. I've used these two relationships to backtrack out and solve for the grams of the aqueous phase. The grams in the organic phase is, again, just this relationship. So if I have 1 gram total, if I subtract off the grams in the aqueous phase, that'll give me the grams in the organic phase. Now, let's say I want to go the other way. I want to calculate the Kd. Well, to do this, if I don't know Kd, I need to know at least 1 mass. So I'm still going to have my volumes, but I am going to need to figure out the grams of one phase, either the aqueous or the organic. And the organic here is probably going to be the easiest because the organic phase is easy to evaporate. So a couple ways we can do this. One, we can just use this relationship, or two, we can use this relationship. So this is probably the easier approach, but there's a lot more hand waving to make it happen, so I'll talk about how to do that second. In terms of this, Kd here is just your grams of organic. Grams in your organic phase is 0.500. Actually, make sure they're not 1 1, 0.150. So 0.150 grams in the organic phase times the volume of the aqueous phase, 150. Divided by the grams of the aqueous phase, well, we've got the conservation of mass, so the total mass minus that, 0.850, times the volume of the aqueous phase, or the organic phase, which is 100. So if I just put these numbers in, I will recover Kd. Now the other way is to calculate the molarities, so convert from mass to moles, divide by the volume in liters, and that will, you can just literally just take the ratios of those concentrations. Bit more work, bit weird to do. This is probably the simpler approach. But these are the two ways to work with Kd, and hopefully that kind of clarifies to you how to work with this in terms of practically how you would separate out compounds.